Good afternoon. Good afternoon. Thank you. Time close to lunch is pretty critical to wake up, so I just thought maybe some voice will help all of us. Mr. Chairman and everyone present here, it's really a pleasure to be here with you on this presentation. Since it's a time just before lunch, I'll try to keep it fast and short. Request to Chairman is on 20 minutes, just give me a warning so that I can wrap it at next 2 minutes of time. This is an integrated geophysical approach for dam health checks and monitoring. Now, I represent a company called Parson. We are basically a geophysical company and we do nothing but geophysics. And we have been pioneering the use of various geophysical techniques for various applications. So there are a number of firsts that we have done, that is GPR in 96 and shear wave in 97. And dam safety investigations we started in 1998. And our first dam which we investigated was Chota Barrage, which was leaking for almost 14 years before that. Kindasani, I was very pleased to see that photograph. It was 15 years back. I don't have that photograph, so I'll take it from you. Alright, so as a company we are working in more than 14 countries. We have office in Delhi and in Bahrain, Egypt and Sudan, and the various countries we are working in. So I'll not waste much time on this. I have been introduced. I'm basically a geophysicist, and we are a rare breed in the country. And at my time there were only 70 geophysicists being produced in the entire year, and I think today also the number has not crossed 200. So we are a rare breed, and we basically try to see what is underground, what is under the surface of the earth. Now, straight away coming to geophysical investigations, the best place to start with to tell people about geophysical investigation is to start with this, because we all can relate to this. I think we all can look at the images, which for example is ultrasound and X-ray and MRI and CT scan. These are the images which we see in our medical reports, because morning also there was a comparison between human health and dam health. So these are the images which we are seeing, and now look at these images. These are the geophysical images, and earlier were the medical imaging images. So here again you have the same kind of images. This is electrical resistivity imaging, this is ground penetrating radar, this is again electrical tomography, and this is a dam in which seismic tomography has been done where the fracture zones are visible on inside the dam. So idea is that using the same kind of principles, that is using different waves and rays from the surface of the earth or a structure, we are trying to find out what is underground, what is in the subsurface. Just like the doctor is doing it on our body, like X-rays, MRIs, ultrasound, we are doing the same thing on the dam body or on the surface of the earth. So this is the very brief just to understand what we are going to talk about. So why we use geophysics and why it is becoming so popular in all around the world is simple, that if you go to a doctor with a pain and he says that I'll cut you open and find out what is inside, what's the problem, I'm sure you're not going to like it. Then why do we do that with the structures or with the earth? There are ways to find out that if you have a pain, they'll find out that you have a stone inside or there's some problem by X-ray or ultrasound. Same thing can be done by civil engineering structures, rather than cutting them open, rather than drilling them. So that's the whole idea. The cost is very low. You're not exposing yourself to any kind of dangers. No drilling, no digging, and you have a lot of information. Of course, the idea is to do it at the early stage, because if you get the operation done, there is no point getting ultrasound done after that. It has to be done at the early stage so that you can decide how you are going to do the remedial measures on the particular structure. Now straight away going to dam investigation. There are various problems which we talk about in dams. There are concrete dams, there are earth embankment dams, there are masonry dams, and the problem can range from crack and degradation in the concrete dams, water leaks and landslide and sinkholes in the earth embankment dams, and water leaks and strength concerns in the masonry dams. And then there are different methods listed here, which I'm not going to read one by one in the table here, but the idea is that whatever is the problem in a particular dam structure, there are a couple of corresponding methods which can solve the mystery, not solve the problem, solve the mystery. That is, what is the origin of the problem, why the problem is there. See, the point is simple. If you are having a problem in your body, the manifestation comes much later. That's the whole idea of doing a regular medical checkup. as it was being discussed in the morning, that you go every year or twice a year or every 2 years, etc., depending on your health condition, the age and all that. So the point is that you are going so that if there is a problem inside, it can be detected at an early stage rather than when it is manifested in full. As they say, cancer can be treated if it is detected early. But once it is manifested completely, it comes to third stage where it cannot be treated. Same thing applies actually to dams also. The big problems in the dams comes to manifestation level when already they have gone through a particular phase of development as a problem. And especially in the old dams, if we can follow some kind of regime of regular inspection and monitoring of dams from time to time, you can detect these problems at an early stage before you actually even see the physical manifestation, and your intervention can be much better and much more effective. So that's the whole idea of doing these investigations. Now the first very effective is electrical resistivity imaging, as we call it. I'm not going in the theoretical background. Now I'm going to show you a lot of pictures. These pictures will give you an idea that what kind of results you get from these methods once you look inside the dam. So electrical resistivity imaging is something in which you put number of electrodes on the surface, whichever surface. It can be dam crest, it can be downstream slope, it can be anywhere, and then so this is how you put the electrodes. This is just one example of a small embankment. These are electrodes you put, and it's on the crest. And this example comes from Mullaperia, which we investigated on Supreme Court directions. So yeah, it's me sitting there. And ultimately, what you get is a section like this. So here you see this is a section, this is the depth, and this is the distance. So it is like cutting open dam at a particular place. So this is, let's say, the dam length from 0 to whatever 200 meters. So it's like cutting open a section there and seeing vertically what is the condition. So this, for example, this was a dam in which there was heavy, profound seepage, and they wanted to find out exactly where the seepage zone is, from which part the seepage is taking place, so that they can plan the grouting operation. See, one is that you do the grouting all over the dam, or you do the targeted, knowing exactly what is the zone thickness, what is the zone width. So there, for example, this zone was detected very clearly. It is based on the variation of resistivity. Earth materials generally are insulators, they have higher resistivity. When they get saturated by water or higher level of moisture, the resistivity decreases. Now that's a simple principle. So this zone, for example, was detected, and this zone was detected. Now here you know the exact extent of the zone, the depth of the zone. So this is the depth, this is the extent. Based on this, the rehabilitation measures can be effectively planned. Because here the seepage was coming out in downstream after around 400 meters, and there was no way to link it from where it is seeping in the dam body. So where the treatment will start.